Okay guys, we're here today to start a new topic. The first thing we're going to talk about is what are machines, how do they work, and something that goes along with how they work, and that is called mechanical advantage. Now, a quick review here, some things that we talked about in previous lesson. Okay, two things to talk about that we need to review before we talk about what machines are and what they do. One of those is force. Okay, because in order to get a machine to work, we have to apply a force to it. Something we just studied here a few lessons ago. Again, a force is any push or pull. Okay, in other words, adding energy to a machine allows it to do our second thing we must remember, work. Okay, and work is simply force times distance. Okay, and you just took a quiz over that. So again, force, any push or pull, we're adding energy. Adding energy allows us to perform work, and that's simply applying that energy over a distance. We're applying a force over a distance. So, what is a machine? A machine is any device that makes your work easier. Now, there are three different ways to make your work easier or to accomplish a task that you would have difficulty doing. And that is why we use machines. One thing it can do is change the amount of force that you exert. Ideally, what you want to do is use a machine that allows you to use less force to get your task or job done. So that is one way that a machine can help you. A second thing, or a second way that a machine can make work easier for you is to change the distance over which you have to exert your force. Okay? If, and we learned this when we were doing our work and power section, if we want to use less force, we got to cover more distance. This is where something like a ramp comes in handy. Okay, even though you're going to have to move it a little bit further up the ramp, you're not going to have to push as hard. You're not going to have to apply as much force, so it makes your work easier. Okay, and finally, change the direction of the force. A type of machine here that is usually used in which we want to change direction would be something like a pulley. Let's say we need to lift something up 10 to 15 feet off the ground. Okay, well, instead of using a ladder and trying to carry a very heavy object up the ladder, what we can do is set up a pulley system. Hook that up to the object and then run the rope or line through the pulley, and then this way we can pull down on the rope and lift the object up to the desired height. So again, three ways to change or make work easier. That is to change the amount of force, change the distance, or change the direction. Now, when we are making work easier or changing the amount of work, what we are talking about is mechanical advantage. What is the advantage of using the machine? Okay, so how many times the machine multiplies the force? When we talk about mechanical advantage, one of the major advantages of using a machine is to reduce the amount of force that we have to use or apply to the object. Okay, we can calculate this, and that is something called mechanical advantage. Now, there are two types of mechanical advantage. There is what we call identical mechanical advantage, and then there is what we call actual mechanical advantage. And you can see here what the big difference is. Is there friction or is there no friction? If there is no friction, which we know there never is, that would be the ideal mechanical advantage. That's what the machine would do for you if there was no friction. Now, since we learned much earlier in the course that there is always some type of friction, regardless, there is actual mechanical advantage. How much force do you put in compared to what you get out? That is the actual mechanical advantage. In either case, we're going to calculate, for our purposes today, mechanical advantage as the force out divided by the force in. What we are dealing with today is actual mechanical advantage. Okay, and in some cases, I guess we will be doing some ideal mechanical advantage also. Either way, we can calculate it. Okay, so force out divided by force in. So a very simple division problem. Okay, now, since you're taking a force divided by the force, there are not going to be any units here. Mechanical advantage does not have any units for you to worry about because forces are measured in newtons. The newtons are going to cancel out. Okay, so you're actually just calculating a number. Okay, remember that. So again, I'm going to do a couple practice problems, and then I have one last thing to talk to you about, and then you can move on to doing your worksheet. Okay, so work in, work out. What is work input? That is how much work you do on the machine. How much force are you putting into the machine? Okay, what are you doing to, or how much work you are putting in a machine? Again, we just learned a couple lessons ago that work is simply force times distance. That's why I mentioned that at the beginning of our lesson here today. So how much force you put in, how much distance are you applying that force? That is what we call work input. Work output is what the machine does. How much force is the machine applying to the object, and how far is the object going to be moved? Okay, in other words, what does the machine do? Work input is what you do, work output is what the machine does. Okay, what is being applied to the object by the machine? So you have to remember that as you're doing your problems here. Now, once you understand what work input is and work output is, you can calculate mechanical advantage. So we have a problem here. What is the mechanical advantage of a machine? It doesn't matter what the machine is, that is applying 200 newtons to an object when you apply 50 newtons to the machine. Okay, so MA is force out times force in. In other words, mechanical advantage is you apply 50 newtons, the machine puts out 50 newtons. I'm sorry, I said that backwards. Okay, you are putting in 50 newtons and the machine gets out 200 newtons. Okay, and that's why it's called a mechanical advantage. You are gaining force by applying your force to a machine or by using the machine. So we're simply going to take force out divided by force in. 200 newtons divided by 50. We have a mechanical advantage of 4. The machine that we were using was making it 4 times easier for you to move the object. Okay, so again, just remember force out and force in. Okay, in this case, I didn't have to worry about distance, okay, because it's simply force out divided by force in. Okay, in this case, you're applying 10 newtons to a machine. The machine puts out 10 newtons, so what is the mechanical advantage? Again, what is mechanical advantage? It is force out divided by force in. We got 10 divided by 10. We have a mechanical advantage of 1. Okay, and sometimes you do use machines, and I'll talk about this later, in which the mechanical advantage is 1. Even though you're pushing just as hard as you're putting as much force into as the machine gets out, there are reasons we have to use machines with the mechanical advantage of only 1. Sometimes you may even use a machine in which you have to apply more force than what the machine puts out. Okay, so for example, here you're applying 2,000 newtons to a machine, and the machine applies only 200 newtons to the object, so why it's mechanical advantage? Again, simply force out divided by force in. You're only getting out 200 newtons from the machine. You're putting in 2,000 newtons. Mechanical advantage is much less than 1. It is simply 0.1. Okay, so you can have machines that give you a mechanical advantage of greater than 1. You can have machines that give you a mechanical advantage of 1. You may have mechanical advantage of less than 1. So let's talk about that. Why have those different types of mechanical advantages? Mechanical advantage greater than 1. This obviously makes your work much easier, like we saw when we calculated the mechanical advantage of 4. Okay, what type of machine am I talking about here? Okay, making your work easier. Usually something called a block and tackle, and that's where we put several pulleys together. Okay, we can use levers, certain types of levers, and we'll talk about levers. There's 3 different types of levers. There are certain type of levers where we can use much less pull, much less force than what we get out of the lever. We can lift something really heavy because of that. That's the ideal situation, or the best possible situation, is using or having a mechanical advantage greater than 1. Sometimes, as we said, we get a mechanical advantage of 1. Okay. Basically, there is an advantage, but there is no mechanical advantage. Okay. You're not gaining from, or the reason they say there is no advantage is because you're using the same amount of force that you're getting out of it. So why would you want to use a machine like this? The main reason, this would be just a simple pulley system, or maybe something like a first-class lever, in which you simply want to change the direction. Okay? Like I said, if we use just a simple pulley system, you're going to set up a simple pulley, put a rope through it. You're going to pull one direction so that you can lift something up. You're going to have to pull with the same weight of the object, or same amount of force of the object, but at least you're going to be able to change directions. Sometimes we get a mechanical advantage of less work. Actually, your work is a little harder from the standpoint that you're going to have to put in more force than what you're getting out. So why would you want to use this one? This is when you have an object that you just need to move a very short distance, so we need to change the distance. So what I'm going to do is I'm going to apply that force maybe over a longer distance, and this way I'll have to put more force into it than I'm getting out, but I will be able to move the object the desired distance I need it to move. Okay, so those are the 3 reasons that you have, or 3 main reasons that you have all the different types of machines that we'll talk about over the next couple lessons. Okay, from here, you're going to do your worksheet. After you complete that worksheet, make sure you are submitting them. Okay, make sure you are submitting them. Again, these should be pretty simple problems. Just remember, it is always force out divided by force in. Have a good day. Any questions, again, email me. I'll get back to you as quick as possible.